This is Module 8, Section 3.2, Graphing Linear Equations and Graphing Special Case Lines. A linear equation in two variables is defined as an equation that can be written in the form ax plus by equals c. This is also called standard form, where a, b, and c are real numbers, and a and b cannot both be 0. Note that the exponents for the variables are 1. The graph of a linear equation in two variables is a straight line always. Linear means straight. How many points are needed to draw a straight line? Only 2. Therefore, if you are asked to graph an equation on a rectangular coordinate system, you need at least 2 ordered pairs. 3 points is better, so you can check the first 2 for accuracy. All points on the line will be solutions to the equation. To summarize graphing linear equations, there's 3 basic steps. Your first step is to find at least 2 ordered pairs that are solutions to the equation. 3 is better as a checkpoint. Plot these ordered pairs on a rectangular coordinate system, and note that the points should all lie in a straight line. If they don't, you made a mistake. Then draw a line through the ordered pairs. Put arrows on either end of the line, indicating continuation of the arrow. All xy ordered pair points on the line are solutions to the equation. So, let's graph this linear equation, x plus y equals 8. All right, to do that, your first step is you have to find at least 2 ordered pairs that are solutions to the equation. Now, to do that, we did that in the previous section, where we found that if you take any equation and you choose any value for x or y and solve for the other variable, that's an ordered pair on the line. So that's what we're going to do. And I'm going to draw a little table off to my left-hand side to keep track of my points, so then I can go over and graph my points and draw my line. All right, so my equation x plus y equals 8 needs to be used to find at least 2 ordered pairs. So I'm going to start by letting my x value be 0. And the reason I picked 0, I could have picked anything I wanted, but I picked 0 because 0 almost always makes your math pretty easy in your equation. So if we let x be 0, our equation then becomes 0 plus y equals 8, or y equals 8. So from the previous section, when x is 0, I found y is equal to 8. That's an ordered pair on my line for this particular equation. All right, but I need at least 2, so I need a second ordered pair. So again, I'm going to take my equation, and I'm going to pick another value. Now I'm going to decide to let y be equal to 0. So over here on my table, I'm going to put in a 0 for y. Again, the reason I chose 0 again is because that almost always makes my math pretty easy. So now I've got x plus 0 equals 8. X plus 0, of course, is x. And x is equal to 8 when y is equal to 0. Now there's 2 ordered pairs. Now I'm going to get a third ordered pair just because it's good practice, just in case I made a math error on one of my first 2 points. So using that same equation, now I'm going to decide to let x be equal to, let's say, 2. Again, you can pick anything you want. So if I put 2 in for x, I've got 2 plus y equals 8. I'm trying to solve for y, so I'm going to subtract 2 from both sides. And I find that y is equal to 8 minus 2, which is 6. So when x is 2, y is 6. Now I'm going to graph those points, and they should all lie in a straight line. If they don't, that means I made a mistake. So I'm going to come over to my graph. Remember, graphing points, you start at 0, 0, you move your x values first and then move your y values from there. So starting at 0, 0, I'm going to move 0 left or right and 8 up. So 0 left or right and 8 up will put me up here on the y-axis at 0, 8. My second point, 8, 0, that's 8 to the right and 0 up or down. So from 0, 0, I'm going to go 8 to the right and 0 up or down. That's 8, 0. And then my third checkpoint says I should go 2 to the right and 6 up. So 2 to the right and 6 up. 1, 2, 3, 4, 5, 6 puts me right there. And then if I had a ruler, I could lay my ruler along those lines and I could sketch in my best straight line. Now I do not have a ruler on this smart board, so that's the best straight line I can draw, but I think it's fairly obvious that those points do lie in a line, and that's a graph of x plus y equals 8. All right, let's do this one. 3x minus 2y equals 6. Again, I'm going to need some ordered pairs, so I'm going to make a table to keep track of that. I'm going to have to pick some values. So I'm going to, again, because I like easy math, I'm going to let x be 0 for one of my points. Then I'm going to let y be 0 for my second point. And for my third point, it'll have to be something other than a 0, so I'm going to choose to let x be 4. You can pick anything that you want. Okay? So starting with my first point, to let x be 0, I would get 3 times 0 minus 2y equals 6, or 0 minus 2y equals 6. 0 minus 2y, of course, is just negative 2y equals 6. You can just think of that 0 as being gone and carry the sign. Now, trying to solve for y, so divide both sides by negative 2, and y is equal to 6 divided by negative 2 is negative 3. So there's my first ordered pair, 0, negative 3. Okay, for my second point, I'm going to let y be equal to 0. So I've got 3 times x minus 2 times 0 equals 6. 2 times 0, of course, is 0, so it's gone. 3x minus 0 is just 3x equals 6. Divide both sides by 3, and x is equal to 2. So I know that when y is equal to 0, x is equal to 2. My third point, I'm going to let x be equal to 4. So I've got 3 times 4 minus 2y equals 6. 3 times 4 is 12. So 12 minus 2y is equal to 6. Subtract 12 from both sides. And I see that negative 2y is equal to 6 minus 12, which is negative 6. Divide both sides by negative 2. And if I bring that answer up here, we've got y on the left-hand side. Right-hand side, negative 6 divided by negative 2 is a positive 3. So I find when x is 4, y is 3. Now we're going to graph those points. 0, negative 3 means 0 left or right and 3 down. So from the origin, 0 left or right, 0 left or right, and 3 down, 1, 2, 3 would be right here. Our next point is 2 to the right and 0 up or down. So 2 to the right and 0 up or down. And our next point is 4 to the right and 3 up. So 4 to the right and 3 up. 1, 2, 3 is right here. It does look like those 3 ordered pairs do lie in a line. So we'll draw the line, put arrows on the end. Label the line is always a good idea. 3x minus 2y equals 6. All right, let's do this example. Graph the linear equation, negative 2x plus 4y equals 8. All right, we're going to keep track of ordered pairs up here, I think. Let's let x be 0 once, then let's let y be 0. That gives us 2 points. And then for our third point, you can pick anything else that you would like. I'm going to go ahead and let x be 2. Okay, so let's start with that first point. We're going to let x be 0. So we've got negative 2 times 0 plus 4y equals 8. Negative 2 times 0 is gone, so we're left with 4y equals 8. And if we divide both sides by 4, y is equal to 8 divided by 4, which is 2. So when x is 0, y is 2. So we put that in our table. All right, our next ordered pair then, I decided to let y be 0. So I've got negative 2x plus 4 times 0 equals 8. 4 times 0 is 0, so it's gone. So we've got negative 2x is equal to 8. And if we divide both sides by negative 2, we've got x is equal to 8 divided by negative 2, which is negative 4. So our second point is negative 4, 0. All right, our third ordered pair, I decided to let x be 2. So we've got negative 2 times 2 plus 4y equals 8. Negative 2 times 2 is negative 4 plus 4y equals 8. Trying to solve for y, so let's move that negative 4. To get rid of that negative 4, which is like a minus 4, we're going to add 4 to both sides. Negative 4 plus 4 is 0. Now we've got 4y is equal to 12. 8 plus 4 is 12. Divide both sides by 4 to get the y by itself. And y is equal to 12 divided by 4, which is 3. So when x is 2, y is 3. So now we need to plot those points. So 0, 2 means 0 left or right and 2 up. So 0 left or right and 2 up puts us right there, 0, 2. Our next point is negative 4, 0. That's 4 to the left and 0 up or down. So 1, 2, 3, 4 to the left and 0 up or down. And our next point is 2, 3. So that's 2 to the right and 3 up. So 2 to the right and 1, 2, 3 up is right here. All three of those points should lie in a straight line, and if I had a straight edge, this would be much easier. But do the best we can here. Looks good. We've got negative 2x plus 4y equals 8, line labeled. All right, now let's graph this equation. Y equals 4 times x. So we make our table, just like the problems before. And initially, you might try to do the exact same thing that I've done on the previous problems. You might decide, all right, I'm going to let x be 0 for my first point, and I'm going to let y be 0 for my second point, and then for your third point, just pick something other than 0 and see what you get. I'm going to start with these two, though. Let's start by letting x be 0. If we let x be 0, our equation becomes y equals 4 times 0. 4 times 0, of course, is 0, and so when we solve for y, we find out that when x is 0, y is also 0. Now notice that since it goes through the origin, since it goes through 0, 0, this can't be your second point because it ended up being your first point. So you're going to have to pick two other values in order to get 3 points, 2 to draw the line and 1 to check. So that's okay. The other thing I want you to notice when you look at this equation here is, although you can pick x's or y's, it's much easier in this equation to choose values for x. Because if you put values in for x, you don't have to move anything around because the equation is already solved for y. So I'm just going to choose a couple more x values because then it's just a one-step solve. All I have to do is multiply by 4 and I'm done. All right, so I'm going to choose to let x be 2, and maybe I'll choose to let x be negative 2. All right, so my equation then is y equals 4 times x. I'm going to let x be 2, so I get y equals 4 times 2. And with just one step, do the multiplication. 4 times 2 is 8. I find that when x is 2, y is 8. Negative 2 is also very easy. If you take your equation now and you put negative 2 in for x, now you've got 4 times negative 2. 4 times negative 2 is negative 8. So when x is negative 2, y is negative 8. Let's plot those points. All right, my first point is at 0, 0. That's the origin. What that means is you move 0 left or right and 0 up or down from that point. So we've got 0, 0. All right, now we've got 2, 8. That's 2 to the right and 8 up. So 2 to the right and 8 up. And 8 is right there. 2 to the right and 8 up. And my next point is negative 2, negative 8. That's 2 to the left and 8 down. So 2 to the left and 8 down. 4, 5, 6, 7, 8 is right there. Negative 2, negative 8. And those should lie in a straight line, and I'm pretty confident that they do. And there you go. There's our equation y equals 4 times x. All right. Graph the linear equation y equals 1/3 x minus 4. Okay. Need a listing of values. I'm going to let x be 0, and on this one I can let y be 0 here. And I'm going to choose another x value again, because if I choose an x value, then I just have to do the math on the right-hand side and I'll have y. I won't have to move anything around to solve for y. So I'm going to choose another x value, and I'm going to choose 3 because I can see by choosing 3 that'll cancel my denominator out and I won't have to deal with fractions anymore. Now another option is you could take that equation and clear fractions if you didn't want to deal with the fractions at all. But because of the values I picked here, I think that the math will be fairly easy, and so that's really up to you. So I'm going to start with x equals 0. That would give me an equation of y equals 1/3 times 0 minus 4. 1/3 times 0 is gone, so we've got y equals negative 4. And there's my first point. All right, if I let y be 0, I get 0 equals 1/3 times x minus 4. Okay, now here I might want to clear fractions, since I am going to have to move stuff around. So the only denominator in that entire equation is that 3. So if I multiply everything by 3, I should clear out all of my fractions. So I'm going to do that. Multiply each term by 3. Remember, this is only one term because it's multiplication, so you only need that one 3. So working left to right, 3 times 0 is 0. That's equal to, okay, here, that 3 and that 1/3, those 3's will cross-cancel out, leaving you with a bunch of 1's. And 1 times x is just x minus 12. Solve for x by adding 12 to both sides. And x is equal to 12. So I know that when y is 0, x is 12. Now that might be a little problematic on my axis because notice that I have a Cartesian coordinate system that just goes from negative 10 to positive 10 in both directions. But that's okay, we can estimate. All right, so now I'm going to let x be equal to 3. So I've got y equals 1/3 times 3 minus 4. Note that that 3 is up in the numerator, And so my 3's will cross cancel. I'm taking a 3 out of top and bottom. 3 divided by 3 is 1. 3 divided by 3 is 1. That leaves me with y equals 1 divided by 1 is just 1, minus 4. And 1 minus 4 is negative 3. So I've got my 3 points. I need to plot those points. So I'm going to go 0 left or right and 4 down. 1, 2, 3, 4. 0 left or right and 4 down. I've got 12, 0, so I'm going to have to go 12 to the right, and I'm going to have to estimate 0 up or down. So from the origin, I'm going to go over 10, and then I'm going to have to estimate another couple. 11, 12 looks to me to be about right there. So 12, 0. And then I've got 3 to the right and 3 down. 3 to the right and 3 down. So 1, 2, 3 to the right, and 1, 2, 3 down puts me right there. And if I draw that line, looks like I estimated pretty close. Straight line, we've got y equals 1/3 x minus 4 when you label your line. Okay? Now, when graphing linear equations, there are 2 special cases that you're going to run into. Case 1 is where equations where the x variable is missing. For example, like y equals 3. If you wanted to, if it really bothers you that there's not an x variable, you could put the x variable in as long as you had a 0 coefficient in front of it. Because you agree with me that 0 times anything is 0, and so 0x really means 0, and 0 plus y is really just y. So 0y plus y is equal to 3 is the same. Now, although you can work with a problem like that, it's much easier when you're trying to graph to just leave it as is, leave it as y equals 3, and take that at face value. If it says y is equal to 3 and you're trying to find ordered pairs, you would agree with me that the only thing y could be in order to make that equation true is y would have to be 3. For example, if you tried to put a 2 in for y, if this was your equation, if you tried to put a 2 in, that wouldn't work. If you tried to put a 1 in for y, that wouldn't work. The only thing that's going to work is if you let y be 3. And so that's what you're going to do. You're going to let y be equal to 3. And x, on the other hand, can be anything you want it to be. You can pick a 1 for x. You can pick a 4 for x. You can pick a negative 100 for x. It doesn't matter because if you think about the equation written like this, 0x plus y equals 3, whatever you decide to put in for x is going to end up being 0 anyway. 0 times 1 is 0, 0 times 4 is 0, 0 times negative 100 equals 0. So x can be anything you want. The important thing is y has to be 3. Now the second special case is very similar, except that instead of missing an x, you're missing a y. So an example of that might be x equals negative 2. Now again, if it really bugs you that there's not a y variable, you could rewrite that and put in a y variable, but you'd have to put a 0 in front of that y. 0 times anything is 0, so there you can let y be anything you want. Okay, so to find ordered pairs, just like before, the only thing that's going to make this equation true is if you let x be negative 2. If you put anything else in for x, you get a false equation. So x has to be negative 2. Y, though, can be anything you want. Okay, you could let it be 1, you could let it be 1/2, you could let it be negative 15. Doesn't matter, because if you put those y values in here, 0 times anything is 0, and it's not going to count anyway. All right, so in case 1, it turns out, and we're going to do examples of this, it turns out that when you graph equations where you're missing an x, you're always going to get a horizontal line. Okay, horizontal, remember, is left to right. And when you're looking at special case 2, where you're missing a y variable, and so you have x equals something, when we graph those lines, you're going to find those are always vertical lines, straight up and down. So let's do some examples. Let's say that I asked you to graph the linear equation y equals 3. All right, easiest way to do this. We're going to get 3 ordered pairs, just like always. Okay, 2 is a minimum, 3 is a better check. That equation says y is equal to 3. That means the only thing you can put in for y is 3. Otherwise, you won't have an equality. Okay? Now, x, on the other hand, isn't even in the equation, unless you want to put a 0 in front of it. So x could be anything that you want. So I'm just going to pick 1, 2, and 3. Let's graph those points. So from the origin, 1, 3 means 1 to the right and 3 up. So we're going 1 to the right and 3 up. Okay, now 2, 3 means 2 to the right, and 3 up. And I picked a poor place to label that first point. 2, 3 is here. And then 3 to the right and 3 up. 1, 2, 3, 1, 2, 3 puts you right there. That's 3, 3. And you can see that those 3 points do lie in a straight line. They happen to be a horizontal line at, notice, y equals 3. All right, let's look at the other case. Let's look at the case where we're missing a y and we've got x equals -2. Again, we're going to take our table. X has to be -2 in order for that equation to be an equality. X has to be -2. Y, on the other hand, can be anything you want. So I'll pick 1 and -5 and 2, we'll say. All right, so come over here. -2, 0 means 2 to the left and 0 up or down. -2, -5 means 2 to the left and 5 down. And -2, 2 means 2 to the left and 2 up. Notice all those lines, points lie in a straight line. They lie in a vertical line. Pretend like that's straight. And we've got a vertical line at x equals -2. Be careful with these problems. 3x equals 7. Now, this is a special case because we're missing a y. But a lot of times what students will do is they will say, well, I'll do exactly what I did on the other one. I'll set up my table. And they just look at the number on the right-hand side of the equation and they'll say, well, x has to be 7. And that's wrong. Because this particular equation is not solved for x. So that's your first step on an equation where you're missing a variable, but the variable is not by itself. It's not isolated. You've got to isolate your variable. You have to get it by itself before you can use the tricks that we talked about in the previous 2 problems. So divide both sides by 3. Now you've got x equals 7/3. Okay? Or since we're graphing, maybe you'd rather have to have a mixed number. So 7 divided by 3, 3 goes into 7 twice, and you've got 1 left over. So that's 2 1/3. Okay, now you can write your table. Here we know that x has to be 7/3. So put that in. X has to be 7/3 for all 3 points, or 2 1/3 if you like that better. Y, on the other hand, can be anything you want. So I'll just pick 0, 1, and 2. All right, so let's plot those points. 7/3, 0, or 2 1/3, 0, is 2 1/3 to the right and 0 up or down. So 1, 2, and estimate 1/3 to the right and 0 up or down. That's 7/3, 0. And then I want to go 7/3 to the right and 1 up. So that'll be the same amount to the right and 1 up. So 7/3 and 1. And then 7/3 and 2 will be 2 up right here. And that is a vertical line if I can manage to draw it straight. X equals 7/3, or if you want to label it with the original problem, 3x equals 7. All right, let's look at this one. Negative 2y is equal to 12. You must isolate the y first, so divide both sides by negative 2. And you've got y equals 12 divided by negative 2 is negative 6. So if y is equal to negative 6, that means your y coordinate has to be negative 6. X can be anything you want, so I'll just pick 0, 1, and 2 again. We've got 0 left or right and 6 down. 0 left or right and 6 down. We've got 1 to the right and 6 down. And we've got 2 to the right and 6 down. And if you draw a line through those points, that is a graph of either negative 2y equals 12, or in simplified form, y is equal to negative 6. So this is the end of Module 8, Section 3.2. You should now complete the homework for Section 3.2 found in my math lab, and when you have successfully completed the homework, proceed to the video for Module 8, Section 3.3.